Order of operations. Order of operations you may have heard of in the past referred to as PEMDAS, and that is kind of mildly useful. P stands for parentheses, and I'm just going to abbreviate that as parens, and then E stands for exponents, and M is for multiplication, I'm just going to abbreviate, and D is for division, and A is for addition, and I'll abbreviate that, and subtraction for S, I'll abbreviate that. So there's your PEMDAS. Now, I don't know if you recall, but there was some little exceptions to this rule. For instance, if multiplication and division occur at the same time, then whichever comes first from left to right will be the operation you perform. Let's take a quick look at an example of that. So if I have something like how about 2 times 4 divided by sorry, I didn't like that one. Let's try something more like 4 times 6 divided by 2. Normally we'll do multiplication first, so we'll do 4 times 6 is 24 divided by 2, that gets us 12. However, what if I had something like, let's try 8 divided by 2 times, let's try, I'm getting myself in trouble again here. Let's make that number bigger than 8. Let's make that number like maybe 20. So we'll do something like 20 divided by 2 times maybe thinking 5. There we go. Okay, so take a look at this guy. You would think do 2 times 5 first, that gets you 10, and then 20 divided by 10 gets you 2. But technically what we're supposed to do is we're supposed to do, since we have both division and multiplication, we'll go from left to right. So this technically will be 20 divided by 2. We'll do that first. That gets us 10. Then times 5, and that gets us 50. Now, technically that's the rule. Although I will admit to you that really the best thing to do if you want to be a good communicator when you're using math with other people is use parentheses and just make it clear. That's way better than just following the rules. This way it'll make it totally obvious to everyone what you're trying to do. Addition and subtraction have a similar concern. With addition and subtraction, if you have both addition and subtraction, you'll do whichever comes first going from left to right. So if I have something like 5 plus 3 minus 4, I'm supposed to add the 5 and 3 first. That gets me 8 minus 4 gets me 4. The problem is what if I have something like 7 minus 2 plus 3? The question here is, am I supposed to add the 2 plus 3 first and then subtract 7 minus that? And the answer is no. That'll definitely get you the wrong answer. What we need to do here is we'll do the 7 minus, again, it's because subtraction and addition, they're actually kind of interchangeable as far as PEMDAS is concerned, if you have both of those, and multiplication and division are also kind of interchangeable as far as PEMDAS is concerned. So in this case we'll do 7 minus 2 first, that gets me 5, plus 3, that gets me 8. Now there would be, I have to say in this case, again, probably the best idea is if you wanted to do 7 minus 2 plus 3, then you should probably write it out as 7 minus parentheses 2 plus 3. In this case, since PEMDAS says do this, it would have probably been a better idea if we had written it out as 7 minus 2 in parentheses plus 3. All right. Anyways, that's some common stuff with PEMDAS. Let's take a look again at some common algebra mistakes that hopefully we can avoid by understanding how PEMDAS works. One really common mistake that we see in algebra class is related to something like this, negative 3 squared. A common mistake is to write this out as 9, because people think of it as negative 3 times negative 3, but that's not what it is. What this really is negative 1 times 3 squared, which we could also write out as negative 1 times 3 times 3. And if you do it that way, you will end up with a negative 9. And that's really the best possible answer for negative 3 squared. Now, it is true if I do negative 3 times negative 3, I will get a positive 9. But in order to write it out like that, we write it out this way, negative 3 in parentheses squared. And what that means is negative 1 times 3 in parentheses times negative 1 times 3. Again, if we use the associative property, we can throw away the parentheses, and if we then, and let's go ahead and do that, and if we use the commutative property, we can then rearrange things. So negative 1 times negative 1 times 3 times 3, and that ends up getting us to be a positive 9. So if you mean negative 3 in parentheses squared, you should write it that way, and that'll get you the correct result. If you mean negative 3 and then just the 3 squared, you should write it this way. Now, one area where this comes in, a very common problem, is with regards to quadratic formula. You might recall this thing, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. We'll be getting to that in a few chapters. But the real problem here is this b squared. This is the issue. What happens is people will see, oh, well, b equals something like negative 5. And what they'll write when they're doing their math is they'll write, well, I got square root of negative 5 squared. And that is not what is meant here. If my b is negative 5, that means that I must multiply the negative and the 5 times itself. In other words, it's negative 5 squared, not just the 5 squared with the negative sign out in front. If you put negative 5 squared into your calculator, like this, negative 5 squared, you'll see you get negative 25. And what we want in the quadratic formula, we want that to come out to be a positive 25. So very important that we write with parentheses negative 5 and then squared. If you do that, you'll be in good shape, and it's because you understand PEMDAS correctly. So anyways, oh, and by the way, again, just to make sure, how does this relate to PEMDAS? Well, in PEMDAS, what we say is you'll always do this exponent, you'll apply that exponent before you apply multiplication. So if I have negative 1 times 3 squared, I'm always going to apply the exponent to the 3 before I multiply. So here what we're saying is the power says multiply negative 3 times itself. So negative 3 times negative 3. That's different. Here we're saying negative 1 times 3 squared. So it's 3 times 3, then times negative 1. Do the exponent first. Here's another expression that people will make a common mistake when trying to simplify. The thing that we see commonly is that somebody will do like x squared plus 9, and that's absolutely no good. X plus 3 squared is not x squared plus 9. And so why is that, you might ask? It sure looks like it's x squared plus 9, but the problem is PEMDAS says you're always going to add things together in parentheses first. Remember, parentheses first, and then we'll apply the exponent second. So until we add those guys together, we're not allowed to go in and apply this exponent to this guy and this guy separately. And so the best that we can do is use the definition of the property of exponents, and what that says is that we will make this simply into x plus 3 times x plus 3. Now that is legal. And we can do something called FOIL, which again we'll be getting to more of later, where we multiply and we get x squared plus 6x plus 9. Remember, first times first, outer times outer, plus outer times, or inner times inner, plus last times last, gets us that. So anyways, that's not x squared plus 9. I have yet another example that I'll show you where a common mistake is made, and I'll show you how PEMDAS helps us to avoid that problem. Many of us are guilty of forgetting to distribute a minus sign. And let's take a look at why we're supposed to distribute that minus sign. It's because technically this is 5x plus 3 minus 1 times 7x plus 4. And I'll remind you, the subtraction rule tells us that subtracting a 1 is just like adding a negative 1. So what we're going to do is we're going to try to visualize this as negative 1 times 7x plus 4. The distributive property says, hey, you've got to distribute this negative 1 times the 7x and times the 4, both. You can't do it to just one. So for that reason, what we end up with here is 5x plus 3, and here it's going to be plus a negative 7x, and then plus negative 4. And again, just to make sure that I'm clear about how this ties into PEMDAS, one of the things we've got going on here is we're trying to add 5x plus 3 to the 7x plus 4. See here the plus sign? But that negative 1 in front says multiply. So because I'm supposed to multiply before I ever do addition, I have to go ahead and distribute this negative 1 here and here first. Then I can go ahead and add all these guys together. Again, you will notice that over here I use the associative property of addition to throw away these parentheses, and I'm only allowed to do that because I have a plus sign here and a plus sign here. So now it's just 5x plus 3. I'll then use the commutative property of addition to move 5x next to 7x, and that gets me negative 2x, and then plus 3 and negative 4 gets me minus 1. And there's my result. And again, thank you very much, PEMDAS and Order of Operations, for helping me to get that result. Here's one that you might not expect to be a PEMDAS issue, but again, it's a commonly made mistake, and PEMDAS can help us to avoid making this mistake. If you visualize this problem as x plus 6 in parentheses divided by 2, what you'll see is that, well, the parenthesis says I got to do this x plus 6 first before I ever try dividing by 2. Now, the common mistake that people make is that they want to go in and they want to cancel the 6 and the 2 and then say, oh, that's just x plus 3. But we cannot do that. It's illegal. We're not allowed to. You've got to add the x plus the 6 first. So definitely don't cross out the 6 and the 2. And it's because of PEMDAS, and it says you got to finish adding these before you can ever divide by these. And in general, I'm going to give you a rule that you should be aware of, is whenever you have this fancy doodad here, this horizontal bar, it's known as a fraction bar. Whenever you have that, there is always something that you need to know about the top and the bottom of the fractions, is that whenever we have that fraction bar, there's what's known as implied parentheses around the top and the bottom. And so we will always treat the top of a fraction bar as though it's in parentheses, and we will always treat the bottom as though it's in parentheses as well. So some extra good tips for you there. Now, as long as we're on this topic of fractions, we might want to compare this with, something like, how about this, 18x divided by 3. It turns out in this particular case, it is legal to go ahead and cancel the 18 and the 3, even though we could not cancel the 6 and the 2. We're allowed to cancel the 18 and the 3, and let's see why. We're saying 18x time in parentheses divided by 3. And it turns out that we can change that division into multiplication. I don't know if you recall, but there's a rule that if you want to change division into multiplication, just change this to a times and then take the reciprocal of the number that you're dividing by. So what we'll do is we'll make this into 18x, and we'll do times 1 over 3. Okay, something like that. And then, since it's all multiplication, 18 times x and times 1 over 3, I can then use the associative property of multiplication to throw away the parentheses. And then I can use the commutative property of multiplication to move the 1/3 near the 18 times x, and 18 times 1/3 is 6 times x. So that's exactly the same result we would have gotten if we would have just crossed out the 18 and the 3. We would have ended up with 6x. Now, that's another kind of general rule I'll try to remind you again in the future, is that you're only really allowed to cancel in fractions when you get the same result as if you had not canceled. So keep that in mind. Here, if we put in a number for x, whatever number you want to, if you try calculating the result here exactly as you see it, you will get a different result if you tried canceling the 6 and the 2. That's why canceling the 6 and the 2 is illegal here. Here, if I put in some value for x and I multiply this and divide, I will get the same answer as when I cancel as if I had not canceled at all. All right, so that is about that.